All right, number 6. In problem 4b, the nominal rate is the stated rate, the advertised rate, 4.75%. What about the EAR? To do that, we'll need to find out how much money did we actually make. Well, we can see that the investment in 4B was worth $12,852. That's after an investment of $8,000. So that's a change of whatever it is. I didn't calculate it. I didn't show it here. That subtraction in blue is the change. Divide by the original. We started at $8,000. The answer to that quotient is 0.606507. Converted to a percent by moving the decimal places 2 places to the right. This money grew by 60.6507%. But that was over a 10-year period, and when you see EAR, the A part stands for annual, the effective annual rate, which is a per year rate. So we need to take our rate of growth for 10 years and divide by 10 to get our rate of growth per 1 year, which is our effective annual rate. And it's considerably higher than the nominal rate. Thank you, compounding. Number 7, how long would you need to leave $2,000 in an account before it became $40,000? Here's the equation we'll use, where t is the number of years. You could be like Anna, and instead of an exponent of 12t, you could just put an exponent of x, where x stood for the number of months. Every time I've done it so far, though, I've used t for years. Let's solve this equation. I'm going to do it algebraically. If you want to do it graphically, that's your choice. But in this video solution, I'm only showing the algebraic solution. Here's our equation. I'll divide both sides by 2,000. And when we do that, $2,000's quotient is 1, effectively getting rid of that on the right. And on this side, 40,000 divided by 2,000 is 40 divided by 2, or 20. All right. My next step would be to take the logarithm of both sides. And when you do that, the property of logarithms states that the exponent can be written in front as a factor. Now I'll start to solve for t. I'll divide both sides by the natural log of 1.0057. And again, when we do that, natural log divided by the natural log of the same number has a quotient of 1, so it's effectively gone. We do the same thing on both sides, of course. I enter this into my calculator on the left. Evaluating that expression, we have 527.06 is equal to 12t. Divide both sides by 12, and there we go. T is 43.922 years. Okay, number 8. Overall, the percent increase is the change divided by the original. When you divide that and get 1.8386, don't forget, move the decimal place 2 places to the right to convert it to a percentage. That's 183.86 percentage. But remember, this was for a 10-year period. Since we're asking for the annual rate, we need to divide that growth rate by 10 years to get an annual growth rate of 18.36%. On number 9, I'm just going to flash these to you. Check your work. Remember, one of the main reasons they calculate the CPI is to measure inflation in our economy. Number 10. This is the formula with a D in it. That's how you would enter everything. If you evaluate inside the brackets correctly, you'll have about 1,755. And after 30 years of putting away $140 a month, you would have almost $250,000. Number 11. If you just stash the money under your mattress, $140 for 30 years, $140 a month, that would only be $50,000. You can see that compounding interest made a huge difference on this money.